the time is now, you're now officially open. So if you want to start off, Rick, I'm sure you know Rick Epping.
Thanks very much, Trevor. In yesterday's workshop, I suggested one possibility for today's workshop is that I can show how I remove nailed reed plates and put them back on the way I learned it in Virginia. And so I think that's kind of a good thing to do. But before getting into that, if there's any questions that any of you might have, other topics before we kind of jump into working on this harmonica here, now would be the time. So please feel free to ask any questions. Trevor, would they speak, or that'd be the easiest way? There's only 10 of us.
Yeah, there is a chat in this room, but due to the nature of the room, you know, it's easier if you unmute and speak.
Right.
You know, but just be a bit conscious that you know, there's time constraints. So I'm sure Rick's got other things to do once he's finished up today. So try and keep, you know, the questions brief, if you know what I mean. So it's not too long an answer.
So the trick is to unmute when you have a question to ask, and then mute again when it's done.
And then mute again, yeah. So just unmute while you're speaking. Thank you.
I have a quick question, please. Just a curious question I thought of the other day.
Okay.
Somebody spoke about having a reed rattle in the CX12 with the cover on, but when they took the cover off, there was no rattle. And I just thought to myself, I wonder if you put the cover back on and maybe burnt out a hole in the cover, would that relieve the tension and the valve might not rattle, since there's seems to be some sort of a vortex when you put the cover on, that maybe you could release the vortex by putting a hole in the cover, or is that just a folly?
I don't know of any. I can't think of any situation in which there'd be a vortex that would be doing it. But what quite often I find with other harmonicas is that the reeds will work fine, but when you put the covers on, because of the added tension that the cover screws put onto the reed plates, in other words, pressing the reed plates, they press the reed plates closer to the comb, that can it sort of pushes one side of the reed a little bit in too far. So if the reed is not quite centered, it might be touching the side. So I think the first thing to do, if you have that situation, is to take the reed plate off and take a good look at it to see, is the reed centered, or are there any burrs? You know, it could be that the reed wasn't quite riveted into the middle of the plate and might need setting sideways, if you know what I mean. Like, say, if that's your reed and that's your reed slot, you know, and it might be aligned this way, but not aligned this way. In other words, too close to one side, and it might need knocking the rivet a little bit to one side to center it at the rivet, and then make sure it's centered at the free end, you know. That would be the first thing that would come to mind that would cause it, but I can't think of any vortex.
Is it valve we're talking about, Rick? Valves.
Right, a valve.
Yeah, the valve rattles when the CX cover is on.
Right. Yeah.
Flap around when it's on. Sorry.
Yeah. Is it a low reed, a low valve? Yeah. That can happen a lot anyway. You know, that tends to be, you know, not that uncommon, and technique can minimize that. You know, how you attack the reed. You know,
I watched your workshop yesterday, and that would probably solve the problem. But I'm just saying, sometimes those valves can be mysterious, and you try everything, and it still rattles.
Oh yeah. It can be. I think very often, if there's too much tension, like I was saying yesterday, that there may be the cover may be causing resistance, air pressure above the valve, so the valve mightn't open up quite as much with the covers on, which means that when the reed is vibrating, the reed might be touching. And so maybe the first thing in that case to do is either to reduce the tension of the valve by maybe bending the valve up a little bit, or like I was saying, trim back the top layer a little bit, and that turning back the top layer is really a really good trick if you want to be able to play really softly, really pianissimo, is to trim that top layer back. But I know what you mean. Sometimes it's just, and sometimes, and the next step, of course, is to replace the valve, and that mightn't cure it either.
Sometimes not. But I was just wondering just to butcher the cover of the CX12 and just get a hot knife and cut out a hole and see if that relieves the tension. But no, it's a bit.
Nah, I don't think so. But I wouldn't do it. But there's another butcher job I did on the CX12. The hard thing about tuning a CX12 is that the mouthpiece really affects the pitch of a reed, and I have this tuning blag. This is an old 280 with the slide and mouthpiece actually screwed on and glued on, with the slide working but with no screw, so that this can go in or out. And when I'm doing rough tuning of reed plates, I can set a 280, a 270, a 260, or an auto valve or an XB40, because they all have the same reed spacing. You can just set it on it, and if it's a top plate or a bottom plate, just set it that way, the other way, and you can get a rough tuning that way. But that's a different, really shaped mouthpiece to the CX12. So what I did with the CX12, basically the same thing. I actually cut away the housing from the mouthpiece housing unit, leaving only the mouthpiece, and I glued the mouthpiece to the comb, and with not leaving the button to work, but removing the spring, so there's no spring. So it's the same thing. I can easily just set the CX12, and that'll give you quite an accurate tuning as well, because it's really sitting properly, and without having to disassemble the whole thing every time you want to change the note a little bit. So that's but as to putting a hole in it, I doubt it would work anyway, and they're awfully expensive to buy for a piece of plastic. So
brilliant tips. Thank you very much. Thank you.
Any other questions? Okay, so move on to removing nailed reed plates. And so let me just take this over to here. Okay, so first thing we do after removing the spring post and the spring and the mouthpiece and all, is take out the, let me get back into camera. Okay, is to remove the cover supports. And I hope this isn't going to cause me any difficulty, because this is an old harmonica, and it hasn't been apart in probably 50 or 60 years. So, but I don't see any rust around the nail, so hopefully it's not going to embarrass me by being difficult to take apart. But then using a knife, pocket knife, pry open the covers. Now the thing is, when you slip the knife in, I start on a corner, slip it in, and what you don't want to do is you don't want to lift up the knife like that. You lift down, because if you lift up the knife like that, you slip the knife in, there it's in like that, and if I raise the knife like that, it's going to put a little gouge on the outside, you see. And so to avoid damaging the outside of the comb, you actually lift it like that, and then slide it through, slide it along, kind of work it up nice and easy, not to lift any side too much at first, because you don't want to really be bending the reed plate. So
If you could just bring that down a bit in the,
sorry.
camera. That's all right, no problem.
Okay, I might zoom out a little bit.
Yeah.
Okay. Okay. Now, where was I? Okay. Now, if you only need to remove one reed plate, say the reed plates are clean, you know, and especially on a chromatic, if maybe the sharp plate, the bottom plate, mightn't be used as much, so there's not really any need to take it out. Then the thing I want to do is, if you don't want to leave a comb with one reed plate on it like that for any length of time, because it can warp the comb. So if I'm only removing one reed plate, what I'll do is I'll take and I'll set it on a block like that, and then clamp it down. Like that. So that way the comb is going to stay nice and flat, and you can leave it like that for as long as you like. You know, if you want to go away for, you know, leave it for a few days, it's not going to come to any harm. So it's nice and safe like that. So you have your reed plate off now, and you can do whatever you need to do, change your reed. And then putting it back, I'll take this off again. Okay, here we have the comb. I always check while you have it off, is there, like this comb is actually pretty clean, but sometimes if it's a well-used comb, there'll be a sort of saliva sediment and dirt and stuff built up there. So I'll do any kind of cleaning in there. I use this little chisel that I've made out of an old reed file, that I use for chamfering reeds and for reprofiling reeds. It makes a great chisel for actually cleaning. You can just get in there and just clean it out nicely, like just very lightly like that. That can clean it out. Work your way up until it's all clean. And the next thing, if you put your nails straight back in the holes, they're not going to hold so well. They're going to be loose. So we always fill the holes. And the way we do it is take round toothpicks and snip them in half, and then take and give it a little tap to fill the hole. Break it off. Am I still in camera? Okay. I see one thing about this old harmonica is that the outer bit is coming unglued there. That's not going to be a problem for us. But anyway, work your way around. Not too hard. And then the next thing to do is figure out what to do with all these bits of toothpick that have their points gone. They're not all that effective in using for kindling. So that I use them a little bit sometimes if I'm applying glue to something, but it's you can compost it. Okay. So there's screws on, and then with a knife, X-Acto knife, I'll get in there and let me put my reading glasses on. Okay, you can get in and trim off anything sticking up, because you don't want any bit of toothpick proud of the surface, because that'll keep the reed plate from lying flat. So just get in there, trim them off. Oops, get in. Okay, and then I might give it a little bit of a sand. So let me show you that here. We'll come over here. Now I have this sandpaper sitting on the workbench, and I wouldn't actually do it here. This is not perfectly flat, but just enough to demonstrate how I do it. I set the comb on there, and lightly work in a figure 8, and I count my strokes once again, and then turn it around and do the same number of strokes, so that if you tend to have more pressure on one side or the other, that'll balance it all out. Just give it a few strokes and have a look at it. Does it seem like that you're taking a bit off of pretty much everywhere? So give that a little sand. And then back over here. Now, the next thing, and this is the one where you...
Can I ask a question, Rick?
Yeah.
What kind of sandpaper do you use? How rough is it?
Oh, that's 120. You know, it's but once again, the coarser the sandpaper, the lighter the touch you want to have. You could use 180. That might be as good or better. I wouldn't go any coarser than 120. I say 120, 150, or 180. It depends on how much you need to take off as well. So I see here that this harmonica, this comb has been repaired. Where am I? Where's the camera? Okay, you can see there in the second cell, there's a crack. And there's a crack all the way down there, so that might cause me a little trouble when we work on it, but we'll just see how we get on with it anyway. So the next thing to do is put it together like this, and this is where you actually have to take a little time. I'll set it on. And I have a couple of smaller spring clamps where you see I've made a bend on the very end, so that at the thickness of the comb, reed plate comb assembly, that it's lying nice and flat. So put that on. This won't be too hard because I'm doing it with one reed plate, but when you're doing two reed plates, it'll take a little time. Now what you want to do, because we're going to be sanding this assembly after we have it nailed, because that surface has to be perfectly flat, and you want to file down as little of the reed plate as possible, So here's where you want to spend a good bit of time just making slight adjustments, and have your best spectacles on, and look carefully. Where am I? Look carefully at, is it proud here? What is one side higher than the other? And like I said yesterday, very often on old combs, these ends where there's more mass, they're subject to more swelling than the middle. So you might often find that these ends are proud of the rest of the comb, and the inner part will be lower. So, but what you don't want to have is anywhere of the comb being lower than the level of the reed plate. Because anywhere where the comb is lower than the level of the reed plate means you've got to file the reed plate down to make it flush. So make sure that, and spend a good bit of time. Don't rush this part, because it's important that you get that right. Just take a really close look under good light and make sure that it's perfectly. And I say this. And what I often do, if you need to make any very slight adjustments, you can just give a little tap it like that, one way or the other, to make fine adjustments on it, and just work around. And also, when you're doing this, be aware that the reed plate is centered properly within the reed cell. In other words, that the rivet pad of the inside reed is not lying between the cell wall and the reed plate, which is going to cause air leak. It wants to be quite close to the cell wall, but not binding under the cell wall. And also that you have enough space for that the inside valve is not going to be rubbing against that cell, its nearest cell wall. So, but y'all can, you can know what I mean, like when you get in there. See, I don't know, you can really, hold on now. Yeah, you can kind of see in there. So just make sure that you've left enough room for the inside valve to open and close without binding on the wall, its wall, and that the inside reed rivet pad is not stuck up underneath the cell wall. And you can even test it a little bit, but this all seems to be pretty good. So once you're confident that it's all the way that you like it to have, then you can start putting your nails in. So, and this is an anvil. Let me just raise this up a little bit. Get this here. This is actually an old clothes iron that was found around the yard, and just to have a good solid surface to nail on. And I just the way I do it is I take my I take the pliers, and I'll hold the nail like that, and mind view, let's see. Okay, looks pretty good. Yeah, set it in, push it in slowly, and then now this hammer that I'm using, I actually ground the one end of it down. You can see, so that it's a very small area there, so that when I'm because if I used I used this end of it, I tend to hammer the reeds as well, or the valves, so that's a little bit too big to be working around the reeds, so I use this here. Okay, so, and just so again, set it in like that. And I find this needle nose pliers has a little grooves in it. Look, can you see them? And you can kind of see the grooves there, and that they're handy for actually holding the nail head. So I can start off with the big side, but once I get down close, I'll use this back side to finish it off. Oh, that nail's bent. I won't use that. Yeah, take a look at examine these nails as well before you put them in. If they're old nails and a little bit rusty, and especially if you've done this more than once, those nail heads can get a little bit loose, and you don't want to have a situation where they break off, because then it's a hassle to deal with that. So oops. Now I have some harmonicas from there's a couple of chromatic players here in Ireland that occasionally send their harmonicas to me, and on some of them I must have changed reeds maybe 8 or 10 times, and eventually you've put, I have enough room that I don't need to use the back. Eventually you've put the toothpick in the hole so many times that you can't really keep on adding more wood into it, and it'll actually crack the comb. So it gets to a point where you just have to be judicious as to, is it one of the nail holes that's right close to a thin part of the comb, where you have to decide, well, maybe that's a little too risky to add a toothpick at that point, and you just have to accept putting the nail in the way it was. This is a little bit of a new experience doing it on camera, but we have plenty of spare nails here. Where are we?
Are these the kind of nails you can buy at your local do-it-yourself shop?
No, these are Hohner nails that I just say. Well, I have spare nails from when I was working in the repair shop, but also some just old scrap harmonicas. I just save all the nails. I don't know where you could actually get nails that would be like this or not, other than, I think Hohner sells nails though, don't they?
Yeah, on the C shop.
Yeah.
With the valves.
Yeah.
I measured the nail from Echo Harp, the tremolo, double tremolo, and it's 0.7 millimeter wide and 7 millimeter length. So if somebody wants to get from China or from the shoe salesman, it's below 1 millimeter thick.
In diameter.
Yeah.
Yeah.
And the length is about 0.7, 0.8.
The Echo Harp is the longest nails, and then there was like at least 3, or if not more, different lengths. I think they were all the same thickness, but at least 3 different lengths. Like the Vampers, like the Marine Band, had the shortest nails, and then chromatics have long, and even old chromatics had longer nails than new chromatics. There was a length that they used in the old days for the chromatics. That's another thing you can sometimes use if you don't want to be adding any more toothpicks, and you have a longer nail, and you think you can do it without cracking the wood.
What about adding glued filed wood, like the remainder of grinding the wood together with glue? Then you can let it harden overnight. It can be a filler, right?
Yeah. I mean, there's plenty of more permanent things. You can drill it out and add a dowel. If you get you'd want to have a pretty good wood. Or I suppose if you had even with a toothpick, you might even be able to use a toothpick if you drill it out and and hammer it in with glue and let it dry, refilling it that way. That mightn't be too hard to do. So let me see here, a couple more nails and we'll be here.
Today you got customizers doing the adventure of converting the nails to screws. So
there is that, and there's one thing that I like about nails that we used to say. I'm not sure how much of it is just an excuse because we didn't switch to screws on the chromatics. Is that if the wood swells with nails, they'll just lift up. But if the reed plates are held in place with screws and the wood swells, it can actually buckle the reed plate. Now, it's not so much of a problem. Not a problem with marine bands anymore because they don't use pear wood anymore. It's all stable, one kind of wood or another, bamboo or whatever else they use. So that wouldn't be a problem there with going with screws. But that was one thing to bear in mind, that I've seen it happen, that if a comb is swells too much and it has screws on it, it can actually buckle the reed plate.
Understood.
Okay, one more nail. Oops. Right, okay, that's all back on now. And now the next thing we do is that has to be sanded down. And let's move back over here. Where am I? Zoom out. Okay. So, give us a little room here. So, you want to make sure that the area between the screw holes is perfectly flat, and you need to have end up with bright metal all the way across. Not all the way to the end is not necessary, but at least to these screw holes. Because if there's a little bit of one the comb or the reed plate is a little higher or lower than the other beyond the screw, that doesn't really matter because it doesn't affect the compression within there. So, but you have to have bright metal between the screw holes. So once again, I count my strokes. Then turn it around and do the same number of strokes. And that's just a bastard file that's set into the machine vice there. And then you have a look. This is actually pretty good. It's just a little bit more right there. Everywhere else you see that it's bright. That's actually bright all the way down. And that just within maybe 3 or 4 millimeters right there is the only thing that's left. So let me just a couple strokes. I'll just do fewer strokes. Have another look. Just about. Yeah, that makes it right to the end. So then tap it out. What we had in the workshop at Hohner, we had an old vacuum cleaner, like a Henry. You know, it's one of those kind of little vacuum cleaners, and without the hose, it was set without the hose, and but it had a kind of a, you know, like the surface of a harmonica reed tester, like a little flat piece of wood covered in leather with a little hole that would play like about 3 or 4 holes at once. And we turn the vacuum cleaner on and run this plate comb assembly along it to remove any bits of brass dust or wood dust in there. There's cotton there, so I don't have that, but I just give it some taps like that and then inspect it. And you're good to go. It's nice and smooth. And then you reassemble it after that. Voila. Oh, there you go. There you go, that yoke. Yeah, yeah. Do you use it, Cathal?
It's a cheapy one and it's not powerful enough, but I do use it just to clean up the dust. But if you had a good one, it'd be more suction. It's not powerful enough.
Yeah, yeah.
Yeah.
So, any questions on that? Anything else that you wanted to talk about or ask about? Maybe we can talk about tuning. Or does someone have a question?
Yeah, sorry, it's Trevor. I was going to say that whenever it doesn't seem so bad with diatonics, but for some reason, whenever I prise an old 270 apart, even though I'm using a very, very slim single-edged razor, it still seems to have like a bow in the middle. So I don't know whether were they ever sort of tension put on while they were manufactured to sort of hold the wood straight, or
a bow on the reed plates?
On the plates, yeah, when I take it off. I don't think I'm levering them. I'm pretty sure, but they seem to just have a burn up.
Well, actually, Trevor, you do want a little bit of a bow. You want a bit of a bow like this, right?
Yeah, yeah, that's what they're doing. Yeah,
yeah. Because if you have it like that, that means you don't have any nails at the front. All the nails, the reed plate is only held on at the back and at the sides, and there's nothing that holds it on there. But if you have a slight bow in the reed plate like that, then pushing it down like that, that's going to help keep the middle part of the reed plate flush and tight against the comb.
Right. Brilliant.
And actually, it's something to look at as well. When you have it apart, take a look at those reed plates, and is there a bow? If there's not a bow, and sometimes you might find that one reed plate will be bowed like that the way you want it, but the other one will be bowed the way you don't want it. And in which case you may want to just carefully put some bins in it, but very, very carefully. Work on it and then take a look at that as well. And it's the same thing you do with the mouthpiece. When you're putting the mouthpiece back on, is to sight along it. Have you got a bit of a bow in there, you know? And if you need to have a better bow in it, then what you can do is, one good way that Walter Rustan worked in the R&D at Hohner. He had a little piece of steel that was just about the right size for the hole, but you can just put the steel in and then kind of work your way down to. It's easier than just sort of putting a bow in it this way. If you have a little tool like that, you can focus where you're putting the bend and just work it down. And you don't want too much, but this is the bow that it came with. To know, can you?
Yeah, the bend is.
There's a little bit of a bend there, and that's on purpose as well for the same reason. And that's to hold the center part of the mouthpiece on nice and tight. That was one of the reasons why that the 260, which unfortunately isn't the tin hole chromatic, is no longer in production. But one of the reasons that some people really like to play that was because there was less distance between the two mouthpiece screws, so that the mouthpiece would actually sit tighter on the harmonica than on a 12 hole or a 16 hole chromatic.
Oh, that's great, thank you. I'm glad it wasn't me that was bending them up.
No. And the other thing that I found that sometimes some reed plates, if you look at this end of a reed plate, right, that I found that sometimes you might have on one reed plate you might have a bow going this way, which once again is not so bad, but one of them might have a bow this way, and that can cause air leak between the channels going that way. So when I was designing the XB40, because I found that if you, and I tested this on chromatics, that if you what did I do now? I think I had some kind of shims, just to test it, very thin shims, to end up putting a slight radius on the comb. Or I might have actually just filed the comb to put a very light radius. And I measured it, and it was only wasn't even hardly a tenth of a millimeter. It was just a very, very small amount, because I figured if you could actually design the injection mold that would, say on a 280, where you have front and back screws, like the XB40 had as well, or the CX12 has front and back screws, that if you have a slight radius on the comb, then you can be sure that when the front and back screws on, that the whole surface there, that they'll actually pull the reed plate down slightly, so you can be assured that it's tight all the way through. And the tests that I made actually did give you a really good seal, but they said that small amount that we wanted, that they couldn't really specify that to the mold maker. It was too small to actually put that into the specifications. But that was another thing to something to think about as well when you're sanding. And when you're sanding the comb there, try to keep your sanding down to a minimum, because you're doing this by hand, and there's no way you can be absolutely perfect. You know, when you're lapping that surface, you're always going to be breaking the edges a little bit. So keep that sanding to a minimum. Do as little as possible, because it doesn't take long to where you end up with it worse than it was before. Kind of like like the old German guy that worked for me said, one of his sayings was, I cut this table leg 3 times and it's still too short. So anyway, yeah, curvature there. Tuning was the other thing. If we can go, I can show you a little bit if you want to just. How are we doing for time, Trevor? You're still muted.
It's 4:20 now, so we've been going for getting towards an hour now. Yeah. About 50 minutes we've been going for.
Yeah. So we've a bit of time. Is there any other questions that y'all want to talk about?
If possible, can we or can you describe very quickly replacing reeds, the riveting, preparing the hole, the reeds, just you know, not the whole process, just describing it so it will be less intimidating.
I'll make a start maybe. So.
Thank you.
This is a tool that Richard Farrell, who was a great pioneer of mail order, it was pre-internet mail order, online harmonicas sales, and he was a real innovator and a real champion for the harmonica, especially the chromatic harmonica. And this was a tool that he designed and sold for changing reed plates. And I have it fixed to an old scale weight. It's a stone or half stone iron scale weight, so it's very stable. Once again, for hammering on it, you want a real strong bass. So that's the first thing when you're riveting reeds. Make sure that you have a good, strong, stable bass. I know I was at the Benci reed factory in Castelfidardo, Italy. Benci was one of the best of the handmade accordion reeds, and they had on their workbench they had a little piece of a little iron bar that was maybe 10 millimeters wide and 15 millimeters long, and it was sticking up maybe about this far, right? But that was sticking up through a hole in the workbench, right at the place where the guy could work. And that bar went through the workbench and was welded on to a steel bar that thick that went all the way down to within maybe 1.5 feet of the concrete floor, and it was welded on to a steel weight that was that wide and that high. So it must have been, I don't know, over 100 weight, maybe 150 pounds or so, massive amount of mass. So that when you struck the reed to rivet it on, it was like solid as a rock, So anyway, this is the tool that I use. Let me see. There's a couple of tools. Richard supplied it with 2 inserts, one with a, one has a hole. You can see that? A hole in it there. So we'll put that in first, and then one of these has a point. That goes in like that. Let me find some scrap reed plate. Let's see here. Just hang on one sec while I grab a bit of scrap reeds. Okay. Okay, one of these will do. Okay. Now, Okay, so the way I do it, take your valve off and clean around the rivet a little bit so you can see your rivet on the underside. And then set it on like that. You see that all right? Do I need to zoom in a little more?
I just put on my glasses, so it's better.
Yeah. And then that way the now you can see that the rivet is sticking up, and at this point I can just grab the rivet, work it off like that. It comes off like that, and then I can put this in and very lightly tap it. Okay, now I remove this one, and the other one is solid. See, no hole. So that goes in next. And we put this insert, which is flat there. That's about looks like about nearly 3 millimeter diameter into it. That goes like that. And just give the rivet, I mean, if you're using a reed from another harmonica, you've got to flatten that rivet hole a little bit. So you want to be tapping very lightly, just a few light taps. Okay, now here on this hole, that's got to be closed up as well. And what I used to use was just this insert here with the 3 millimeter diameter end, and to pound it down. But that actually sometimes would take a good bit of pounding before it would be closed up and flat enough. And you can see from over the years that this that's been pounded a lot. That was flat when it started off. So what I did instead a while back, I just took a nail, cut the head off it, and ground this down to a point it's only about not much bigger than the rivet head. That's about maybe 1.5 millimeter diameter. See that? And I put that in, and with this, I can, with much less pressure, just center that right over the hole and give it a few taps, and do it on the underside as well. Okay, and the other thing is that, where is it now? You can see that the depression that it makes is only a little bit bigger than the hole itself, and the main thing is that it's less than the size of the rivet pad, so the rivet pad can still lie nice and flat on the thing. So then I take a rivet. Let me find my rivets here. Yeah, here they are. And I guess you can buy these from Hohner as well. And the Hohner there's a number of different size rivets.
Yeah, I got one of these. The pole you can break
Yeah.
one off.
And there's longer ones for. There's a couple of different lengths. There's really long ones that was used on the Super 64X, and there's some that have a slightly bigger diameter as well, and that's something to bear in mind. If you've changed that reed a number of times and the hole it gotten so big, it's really difficult to get the hole in the reed plate down enough to make the rivets bind. You can use a rivet that has a slightly larger diameter. What was I going to say about that? In any case, let me just change this back to, take this out, put the insert that has the hole in it back in there, and put the one with the 3mm.
Rick, sorry to interject just quickly.
Yeah.
I'm just going to leave the room. I've got to go and do some checks on someone. I'll be back in about 15 minutes or so.
Okay, Charlotte.
Cheers. Thank you.
See you in a while. So we have that. Now, the first thing we're going to do is the rivet hole in the reed plate. It may be just the right size. It might be a little too loose still, or it might be a little too tight. So, that's what I want to say. These type of rivets, Stiftnieten or stick rivets, it's not the head of the rivet that's really holding the reed in place. It's the side of the rivet. That the rivet diameter is that much slightly larger than that of the reed or of the reed plate. So this wants to be fairly snug. So you put it in and you just kind of feel how far up it goes. And I just feel it's just about right. It wants to stick up enough. It wants to stick up enough that when you set the reed in place, that it'll be centered. So I have it now. Oops, I've broken it off. That's the idea. When you have it in, sorry guys. Okay, that actually broke off with a spare one there. So I'm just going to snap off the other one. Okay, and this is actually it's only sticking up a little bit less. I would like to have a little more of the rivet sticking out. So I'm going to very, very lightly tap it in a little more. Just a few taps. And take a look at it a little more. Okay, there's that. And then your reed, set the reed, camera. Okay. Set the reed in place. Okay. Reed is sitting in place like that. And then turn it upside down. Set it on like that. Am I in camera? Yeah. And then okay. Now the reed is sitting there. I can move this out of the way. Oh, I can't move it out of the way yet. You can see the reed is on like that. And at this point, what I'll do is I'll hold it up to the light to see is it centered, especially if it's centered this way. Like that's not a problem. It's bound to be a little off, but you want to make sure that it's centered this way. And if it's not, if it's one way a little bit one way or the other way, then what I'll do is I will I'll take a little screwdriver and just set it. I'll do it this way so you can see it. Just set it right like that at about a 45-degree angle, and then just give it a little tap to knock the reed one way or the other, just to make sure it's centered. And the rivet is still only half tight. This one actually is pretty good. So at this point, I'll center the reed a little bit with a reed wrench, and what I do is I'll actually hold the free end of the reed in the slot, because what you don't want to do at this point, you don't want to be moving the reed back and forth on the rivet, because if you do that once or twice, the reed is going to be loose. So you would actually move the reed as little as possible, and that way, if you put the tip of the reed with your finger down into the slot, the reed is only going to be able to move just a tiny bit, you know. So hold it in, center it, and give it a little half. Oops, different one. You change back to the anvil one, the one without the hole. Flat surface now. And oh, the other thing I do is I like to actually file the tip of the rivet a little bit, because that's a pointed rivet, and when you're doing it by hand, it's a little too high, and it can sometimes move one way or the other. So I'll take a file and just file the tip of the rivet a little bit.
So you leave less material for error.
Yeah,
just enough to hold the.
You leave enough just to hold it on. It doesn't take a whole lot to hold it on, because, like I said, most of the pressure that holds on is in the shaft, not the head. So I've still got at least a millimeter of rivet sticking out, and then at this point, hold it in like that, and hold my thumb over the reed. Don't kind of hold it in, because there's one thing about all of the Hohner reeds, except for the MS series, they're not parallel. They're actually trapezoidal. The reed is wider at the rivet pad, not so much as you'd even notice it when you look at it, but it actually is wider at the rivet pad than it is at the free end. And this makes it a little easier to center the reed. The MS series diatonic are not. They're actually parallel, because they were originally adjusted and centered automatically by the robotic machinery that used kind of lasers to center it. And if you had a tapered reed, there's no way that the machine could measure the distance from one side to the other. So they're parallel. But all these other ones are trapezoidal. And so you put your finger on like that, give it a few taps, and then check it again to center it. And this is actually slightly off to one side, so I'll show you how I do that. Let me lower this down. Okay, that's going to want to go this way a little bit. One more little bit. Okay, I should do it. And then at that point you can make your, do your adjustments, line it up. Now, one of the things when you're setting a reed in is that you want to have the back part of the reed kind of down into the slot. And the way they used to do it at the factory was they would just, with the fingernail, push the reed down a little bit. And that's a good way to do it. I actually have a little tool that I use. Where is it? Here, this one. It's like one of my chisels, but it's a little wider, and I've actually polished a radius on the end so it's not sharp, so it won't scratch it. And what I'll do is I take a bit of shim stock like that, and I'll set the shim in like that, and with this tool, zoom in a little bit. I'm in. Okay, with this tool, sort of push down, starting back maybe 2 millimeters or so, work it in sideways like that, rocking it a little bit back and forth. Now, one trick is to maintain the offset that you want. If you have, how far in you put this shim is going to affect what kind of offset you're left with. So you want to look at what kind of offset this has. This has a little bit, the offset's a little bit high here. So if you move the shim back a little bit away from it, and you do that same technique, that's going to lower the offset. If the offset's too low, if you push it in, further you push it in and you work it like that, that's going to raise the offset. So that way you can spend less time manipulating the reed, because one of the things to bear in mind when you're working with reeds is that you want to mess with them as little as possible. You know, if you're bending the reed up and down to adjust your offset, you know, you're adding stress to the reed to the point where you could actually strain the reed. So try and work with the reed as little as possible. So if when you're lowering the back of the reed down into the slot a little bit, and this is not a whole lot, if you do it by keeping an eye to your offset and moving your shim in and out, so that when you have it down as far as you want, your offset is close to where you want it, then you're messing with the reed less. And one way, when you're lowering it in, you can kind of look on the underside of the reed. Let me see, can we pick that up at all? You can see, look at one of these undersides of the reed there. You can see the bit of light in there. And what you want to have happen is that when you lower the reed into the slot, that the reed should close the slot pretty much all at the same time. And that's going to give you better response and better tone, more signal, less noise. If you have the curvature such that that one part of the reed will close off the slot before another part of the reed, say if the middle closes it off before the end, you may have too much curvature in the reed. You want to decrease the curvature, but also if you don't lower the back, sometimes you'll notice that even when the reed is down flush with into the slot, that there may still be a little bit of light back at the rivet end. So that you want to get that down a little bit, and that's the way I do it. I do it with this tool, and I use this bit of shim and adjusting it back and forth so that I'm minimizing the amount I have to adjust it later on for the offset.
That's a great explanation. Does the curvature or profile influence the buzz, the springiness of the reed? Because I bump into reeds that are fading and those that are springing happily and with great tone, and there is a difference across the reeds. And sometimes I thought I should hammer the rivet a bit to tighten the attachment to the plate, and it didn't really solve anything.
It was always said at the factory that you actually do not want to have the rivet too tight, or if you have screws. And one of the reasons that screws that I think are maybe not as good, because with the screw, it's really the screw head that's that's holding the reed down, and that wide head that's holding the reed pad down is actually restricting the vibration, because a reed is actually vibrating not from the free tip to the end of the slot. It's actually vibrating all the way to the rivet, so it was always said that you really want the rivet tight enough so that if you drop the harmonica or drop the reed plate, the reed is not going to shift out of. The reed will be stable, but you don't want it any tighter than that because it can restrict the vibration. And another example of this is when the MS harmonicas were first made. They call them teller neats, or like a plate neat. They had a big wide head on them, and it was found that wide head was holding the reed down so tight that we were losing response, and yet they needed to have a wide enough head so that the machine would be able to pick up the rivets and put them in place. This was a machine that was built in Switzerland by the same company that built the robotic machinery for the Swatch company. You know, the Swiss watch company that made sort of affordable robotic made watches, the Swatch. So it was the same company that did that. And so we couldn't eliminate that type of plate or teller neat because it needed it for the machinery. And the only thing we could do was to have the underside tapered so that the rivet, instead of looking like this, would look like this, so that there was actually less that was actually in contact with the reed. But even that was not as good as the stick rivets that the diatonics used. And eventually, when the robotic machinery kind of gave up the ghost, and they changed to the standard stick rivets like we use on the others, and it made a much better sound. So tightening the rivet too tight is not going to do it as well. But back to the point that you were making was, the springiness of it. Adjusting the curvature is not going to really change the flexibility or the springiness of the reed. What it will do, it will change whether or not, or how much, when the reed passes into the slot, it'll change whether, if it's too much, then when it goes in, the back part covers the slot first, and then later on the tip does, you see. And that's going to give you poorer response, you know, more breath in it. If If it's too much the other way, and the curvature is very, very slight, just enough that it comes down at the same time. And the amount of curvature that's needed, it's not necessarily the same for all reeds, because low reeds are generally thin at the rivet end and thicker at the free end, and the very smallest reeds are very thick up at the back end and very thin at the front. So the back end is pretty much straight. There's hardly any curvature on those highest reeds. So you need to just kind of, it takes a little practice and messing with it a bit, but looking at it from underneath, to see the light as you close it by hand, to see that it closes at the same time. That's important. Another thing, of course, is whether that reed is too stiff or not to begin with.
Could you expect from too tight of a reed to the plate a shorter tone, like fast vibration and that's all, and not to continue the tone, something like
less resonant.
muffled or shorter tone, right?
Yes, shorter, like less resonance. When you ping it, it won't have such a longer decay. That's a sign of a good reed. That when you pluck it, it has a long resonance. Yeah. And if the rivet is too tight, that will affect that. Yeah.
It's the opposite that what I do for diatonic harps, because I play overblows and I don't want too much vibration. I want the vibration to be controlled with air, and when I stop, it must be stopped. So I even put wax or nail polish on the edge of the rivet in order to stop the vibration as soon as possible, because if not, it will continue to vibrate on the reverse movement. So this is the opposite. I need to let it vibrate and not.
That's interesting.
Yeah, it's the opposite from what I'm doing so far, because I switched to chromatics and now I'm facing new stuff. So it's interesting.
I never thought about that. That's a good point. Yeah, but that's something that I really have done. I know very little about. I mean, I tried overblowing. I learned about it from Will Scarlett probably around 1980 or 81, when we were both living in the San Francisco Bay Area.
When I was 8.
That's right. No, not. It was even before that, because it was in the early 70s, because I was traveling up there. I moved to Ireland in 73, and I knew about it then because there was I could only overblow the 6th blow, and not very well. But an album that the group I was in, Pumpkinhead, had made an album in 75, and there's one overblow note on the album, and but even that note, they had to really mess with the EQ to make it sound anyways nice. So yeah, so I gave it up by the late 70s, and it was like, I knew it was too hard for me. So I don't know a whole lot of what's required in terms of setting up a harmonica for overblowing. It's interesting to know that, though. I never thought about that.
That's in the diatonic week, not the chromatic week. Something else. So yeah, I think I need to loosen it up somehow. Do you have any tips to loosen the reeds where it's just muffled tone or too tight? Make it vibrate more.
Are you using rivets or screws?
Rivets.
Yeah.
Not yet screws. I'm not liking that. I prefer to keep everything in the same way, not some parts of. I'm not playing a lot of soldered reeds, only riveted. So if I play Suzuki and something will be messed up, I think I will just get a plate. But on every Hohner or Tombo or something else, I prefer to keep everything. This is why I want to learn how to replace those. Not just switch to another 270 or Deluxe or something, right, to be able to maintain my harps.
Yes. So yeah, like I say, the it takes only a few turns of adjusting, centering the reed, with a reed wrench, a few turns like that, and the rivets and the reed's going to be loose. So if that's the problem, if the reed is too tight, you can loosen it a little bit, just a couple rock it back and forth once or twice. But one thing that I do sometimes when I'm embossing a reed slot, if I find that it's very close, but there's just a little bit of a buzz somewhere, that rather than taking down the, burnishing back the embossed edge of the slot a little bit, I might just take the tip of the reed and hold it in and then rock it back and forth. So the reed is only going to be moving, you've only got maybe, a couple of hundredths of a millimeter clearance on either side, so that you're not going to be loosening the rivet at all. And you could actually put a bit of force on it, push it against one side or the other, back and forth. And that can, if the problem is up at the free end, that can kind of clear it a little bit.
Some people are actually moving the reed aside from the slot to handle the slot and not handle it while the reed is inside. So I think the system of keeping the reed inside is best, because then you don't weaken the rivet, and you need actually to pull it and reassemble it. So they were twisting it aside and working on the slot and then getting the reeds back, and there is no measurement there. There is no logic in doing it.
Yeah, and you end up with a reed that's too loose as well.
Right.
And sometimes, especially with the new harmonicas, the tolerance is pretty good, and some folks are only embossing the front half of the reed and then chamfering the whole reed as well, because chamfering has it doesn't close the tolerance, but it has the same effect in terms of response as embossing does, by giving that sharp edge to it. And so you might just try, unless you have your technique. It takes, sometimes I'll emboss the slot the whole way down, and it's very fastidious when you get to the back end of the reed. But if it's a good reed plate to begin with, then it might be sufficient just to emboss it as far back as you can go without just pushing the reed into the slot too far, and then chamfer the whole reed. So do you chamfer the reeds at all?
Just a little bit. I was saying chamfer instead of embossing, but I will get there also. It's like the 80-20. If you can do the 80, leave the 20. If you don't have to go 100% to improve something. If you improve 80%, so it's better than nothing or half. So this is better to keep everything in health and just go as far as you can.
Yeah, and I think that philosophy works for recording music as well. The fella I worked with, the producer, he always said, if it's 85%, it's good enough. Leave it at that.
Better than 80, right?
Oh yeah, oh right. Well, he said 85, but same idea. 100% is you get 100% with one thing, and you've ruined it in terms of overworking it. Generally, unless you're the natural born maestro.
Suppose I were to start my own workshop, what would be the basic equipment I need?
I think some of the harmonica toolkits that you can buy, they're probably all okay. I know Lee Oscar used to sell one, and I'm sure Seidel probably sells toolkits. I know Hohner does. Start off with something like that. There's some tools you can make yourself. A lot of the tools I made myself. This reed wrench I made myself out of some spring steel. you know, you can with hammers and pliers and things, you can kind of put that together. Like I say, you need a good anvil. What else do I have? I've got lots of bits and pieces, things like this. This is a oh, I've got the wrong. Sorry, I got the wrong. This here, I use that for adjusting the offset of the reed. See, that's a very thick piece of reed plate, right? And it's got a thin blade on the end, but because with this being as stiff as it is, when I'm using it to adjust the offset, then any bending that I feel, it's all bending of the reed and not the reed slip. So it's a little easier if you use a stiff reed lifter like that to feel how much pressure you're working on. I think if you get the basic toolkits and there's probably a lot of online. There's a couple of videos that I put up that are available on YouTube that show me working on reeds, and you'll maybe get some ideas there.
Would you need a toolkit for each brand? Because I like to play different brands for different purposes. Would you need a Seidel kit for Seidel and a Hohner kit for Hohner, or?
No, I don't think so. I think most of the tools will probably work for the different brands. I think so. I think there was one brand where the rivet pad was not the same width as the Hohner, and the reed bridge wouldn't work very well. But most other files and scrapers and things like that could be used on any brand. One thing I'll say when it comes to scrapers or like the chisel that I use, like this is I don't think you'll get this in any toolkits, but it's something that I like to use a lot. I use this for chamfering the edge of reeds, and I think I might demonstrate that in one of my videos. But it wants to be sharp, so having a really sharp tool is important. And one thing I could show you in terms of tuning, this is a reed scraper, and I think this comes with the toolkit as well. And when you're doing fine tuning, you already have the harmonica. The reed plate is screwed on to the comb, you know, because even if you're just holding the reed plate onto the comb, it's not going to be quite the same as when it's actually fixed to the comb. So the final fine tuning is done with the reed plate actually mounted. And say if you want to tune an inside reed, one way, say you want to tune an inside reed down, lower, and that means removing material from towards the rivet end. Now, if you do it like this, say sticking in this reed, I have the long thin reed slip. This is very thin reed material. This is only 0.3 thickness, and it's very long and narrow, and you can slip that in like that. You see that sticking out there? Can you all see that? And when you have it like that, then you can raise the pitch of the reed. You can, if you're careful, and if the reed is not too small, you can use a file. Let me put my glasses back on. You can use a file, get in there and file it like that. Or you can use a scraper to get in. If it's a very high reed, you got to be real careful when you're filing in that direction that you don't catch the tip of the reed into the grooves of the file and destroy the reed. So sometimes on the very fine ones, if I'm raising the pitch, I'll get in there. I'll show it up on here without the slot, without the valve, that like that. I might then just see that, yeah, get in, and I might scrape back the way, like that. Because at this point, it's only very fine tuning, and you don't have to be taking much. The only thing about going in back the way like this is sometimes it'll leave a little burr on the tip, and that you may have to take that off. Sometimes just plucking it off will do it. Now the thing is, though, if you want to lower the pitch, and you can support the reed like that, you can get in and scrape it like that. And let me do it with one without the valve, so you can see what I'm talking about. I'll just remove a valve here. See this one. Okay, just take the valve off so you can kind of see. If I were to support the reed like that, and then you're getting in under the valve, you're working like that. And if you do it like this, right, sometimes that's going to affect the offset and the curvature if you're working from here, because you can see where the reed is actually bending down as you're pressing on it. So what I like to do, but it takes a really sharp scraper to do it, and I'll show you in a second how I sharpen them, is I get in and raise it up like that, and then hold the scraper down low, right? And you have to kind of watch to see that you're not damaging the valve, right? But you get in as far as you can, keeping this down really low, and as far as you can get back without it damaging the valve. And you can get it back far enough that back there, the reed is quite stiff. And then you can actually, unsupported, you can get in and scrape it like that. And you haven't damaged the valve, and you're not affecting the offset at all. You know, and you don't need to readjust the reed afterward, the offset. But sometimes, like on these, and in general, the thing I like about the scraper is, rather than filing the whole surface of the reed, is that when a reed has been played, it builds up surface tension, which is not a bad thing. You know, it's what you kind of need, and that gives you a stable pitch and everything. If you're filing, say, to lower the pitch of a reed, and you're filing across the whole surface of the reed, you're removing that upper layer that has developed the tension, you know, like the work hardening, and that means that over time that reed has to redevelop its tension, and the pitch is not going to be stable. It's going to require more tuning later on. Whereas if you do your tuning with just a scraper like this, then as you remove metal, you're only removing a little bit of the top surface. And these are the same tools that I used for years with accordions. Like this one is an accordion scraper. You see, compare the two, you know. And actually the accordion ones that have inserts there, right? And they come in different thicknesses. But it's the same principle. And so if I'm lowering the pitch of a reed, well, the way I do it, rather than fining it, I'll put a reed, a bit of a shim underneath like that, and then just scratch like that. You can see, where is it? Where am I working? Now you can see the little scrape. See that? And depending on how much you want to take it down is how far up you start. Now there's an interesting thing about reeds. You know, you remove metal from the free end, the pitch goes up. You remove metal from the rivet end, the pitch goes down. But that means that there's a point along the reed at where you remove metal and there'll be no change. Well, I did some tests years ago at Hohner, and I found that most reeds, even big or small reeds, that 0 point where metal removal doesn't change the pitch is not halfway. It's 2/3 of the way from the rivet to the free end. So it's actually only 1/3 back from the free end and then 2/3 to there. So when you're lowering the pitch, you can actually, if you can start all the way from halfway, like you get up to 2/3 and there's not going to take anything off. It's not going to change it as well. But you've got a good halfway that you can actually remove metal if you have to lower the pitch. Although it's going to have more effect here, but you can work with that much if you want. And then for the very finest, you can take a little more. You just take a little bit like that. But like I say, especially if you're working in like that and you want to lower the pitch unsupported, you don't want to be pushing down hard at all. It has to be very light hand. So you, as you're in like that, you kind of rotate as you're kind of testing it, you rotate the scraper till you find a point that's especially sharp, and you'll feel it when it's actually sharp. And so I'll show you now what I do to actually sharpen them. For years, I just would run it by hand, like I'm going to do it with my left hand, you know, like that. But you know, keeping it straight by hand is a little harder. So what I did, I made a little jig, just a little block of ash, and drilled a hole. And I actually have two size holes, one for this one for the harmonica, one for the accordion scraper. But and I have it drilled so that it's I can push this in so that the tip of the scraper is just slightly proud. See that? And then on the stone, I actually use spit as a lubricant on the stone rather than water or oil. And I learned that trick from the old German guy that worked for me at Hohner. He started off, he was an accordion player and a guitar player, but he was a tool maker by trade. He was from Obendorf, which is the village up near Trossingen. And he said that when they'd be making machine parts on the lathe, that they got, if the foreman was there, he'd make them use oil to lubricate the parts. But he said if the foreman wasn't there, they'd use spit on the lathe, because he said you get a much better finish with spit than with oil. So I put a bit of spit on the thing, and then work it and hold it lightly and just kind of keep working it. When you think you kind of more or less have enough, you can increase the pressure a little bit until the point where you're down on just the wood, and then that can give you, it's nice and flat that way. So that's always sharp, because like I say, it's really important that this scraper be sharp when you're using it, especially anytime you're using it. If it's a dull scraper, that means you got to push harder on it, and that kind of work hardens the piece. So good sharp tools always.
Cool. Rick, I'm conscious now of the time. I mean, you've been going for hour and 3/4 now, so you'll probably want a break now. So I think this is probably a good point to finish up, if that's okay.
Yeah, it's fine with me.
I feel bad doing it, but I'll show you.
Oh no, that's quite all right. Thanks for looking after our well-being, Trevor.
No problem.
Any other quick questions that anyone has?
I have your tools I got from Richard Slay here, Rick. This one here.
Valve tool. Yeah.
The valve tool, yeah. And then various Richard Slay tools here.
Yeah. Oh yeah.
That one, and he has this is a nice one here for embossing.
Oh yeah. Nice.
And then another one here.
Lovely.
Embossing. And then you have these ones here. They're all Richard Slays.
Yeah, well, I would, Eric, I would definitely recommend checking Richard Slay's site, because he's quite innovative, and he makes good tools. So yeah, he's definitely someplace to look at when you want to start setting up your own. And he's got a lot of videos as well, doesn't he, Richard?
Yeah.
Showing you how to use the tools.
I got these light boxes as well, but I didn't make it. It's made out of cardboard.
Right.
But I have the top bit's wood, but the rest is cardboard, and it's for temporary. But I can stick my phone in there, and it comes up through here, through the slot here, and I can use this embossing tool with my magnifying glasses, and
good.
You know, it's really quick, very, very quick, and comfortable and interesting to do, you know. So
fair enough.
Yeah.
Right, well, guys,
he has this tool as well. Oh yeah, but you were saying that it might not be you're better off with, I think you're right though, you're better off with that tool there, the scraper. He has this one here, see?
Oh, it's a draw scraper.
A draw scraper, yeah.
Oh yeah.
Yeah.
It takes too much of the
whole surface
off,
off, yeah.
Now the one thing about that is, if you need to reprofile the reeds, and that shouldn't be a problem. Most reeds are pretty good now, but when Hohner, when we switched from the ZA5 brass reed material to the phosphor bronze, that material was much harder than the old brass. And the initial production, they made the profile of those reeds, that sort of the milled profile, the same, and that made those actually reeds too stiff, and it caused a lot of reed breakage, because the reed as it swings through the slot, it doesn't swing like a pendulum. It coils and uncoils like a clock spring. But with the reed too stiff, it was actually working more as a pendulum, putting too much strain there and causing them to break. So sometimes when you're working on reeds, you might want, and this might be useful for overblowing as well, something to experiment with, that maybe you want a reed that's a little more flexible. And doing that, you can take down the whole reed, and I'll use that with my chisel, and Richard's draw scraper might be a tool to use as well that will work for that. But that's, you know, that's a whole other story. Okay, guys.
Well, I can say thanks very much for doing this, Rick. Great yesterday and today. It's really appreciated. So thanks for helping us out. You know, it's priceless gems there, non-stop. So you know, it's certainly plenty to take away there. We'll let you know when the recording's coming up and sorted out and whatever. So you know, to use it as you wish. And as I say, thanks again. I'll give you a round of applause and for your
Wonderful delight.
yeah, it's been a wealth of information. So if you want to move yourselves back into the main room, thank you all for attending.
Thanks
And
for coming. Enjoy the rest of the festival.
I will say this is all donation based, so if you want to throw something in the pot, you know, it all goes towards the artists that have done workshops for us. And so, you know, as I say, it's a nice free weekend, so, you know, I haven't had to leave your armchair. So there we go. Thank you all very much. See you in the main room.